Hello, everyone, and thank you for checking out this session. My talk today will be covering the new batching enhancements that were recently added to Spring Data JDBC. First, let me quickly introduce myself. My name is Sharad Taylor, and I started with Pivotal, now VMware, back in 2016. All the while, I've been providing consulting services as part of the Labs organization, working alongside clients on their journeys to build software better. Most recently, I did a short rotation onto the Spring Data team, where one of my biggest contributions during that time is the topic of this very talk. Whether or not you are already familiar with Spring Data JDBC, batching as a concept is fairly universal in the world of relational data access. For the purposes of this talk, we'll start with a simple definition of batching so we can consider the enhancements through a common lens, and we'll quickly touch on what makes batching a desirable feature in the first place. Now, as an ORM, Spring Data JDBC is designed to encourage modeling your domain following the ideas of domain-driven design. In order to understand how batching is implemented in this module, we will need to introduce a few core domain-driven design terms and ideas. With that foundation, we'll look at examples to see how various data access operations were enhanced to use batching. Next, we'll review the list of JDBC dialects that support batching through Spring Data JDBC and describe why others do not. Finally, we'll end with instructions on how you can get batching support for your project. With relational data, every database operation is carried out using SQL statements, and batching is the grouping of multiple SQL statements together. While this grouping can be done in a few different ways, for our purposes, we will only consider batching where multiple SQL statements are grouped into a single SQL statement. For example, sequential insert statements that are written in this way can be written as a batch insert statement as follows to produce the same effect. Likewise, sequential delete statements that are written in this way can be written as a batch delete statement as follows to produce the same effect. Using this technique, updates that would normally require multiple statements can be carried out using a single statement, making these operations more efficient. Batching in this way reduces the number of round trips to the database, saving on network traffic, and reducing the overall latency incurred by the operation. What's more, some database implementations may also include further optimizations in executing statements that are written as a batch update. With Spring Data JDBC, all data access operations are organized around the domain-driven design concept of an aggregate. An aggregate is a cluster of entities that model a set of business rules with transactional consistency. That is, all changes to the aggregate must be atomic and always produce an aggregate whose state is immediately consistent with all the business rules which it models. The single point of entry to the aggregate through which all these changes are made is referred to as the aggregate root, and Spring Data JDBC provides a repository implementation for each aggregate root to persist the changes to the database. Spring Data JDBC is designed to be a simple ORM that does not offer many of the complex features of JPA, such as caching and lazy loading. As a result, the rules it employs to translate changes to an aggregate root into a set of SQL statements is conceptually very straightforward. If the aggregate is new, this results in an insert for the aggregate root, followed by insert statements for all directly or indirectly referenced entities. If the aggregate root is not new, all referenced entities get deleted, the aggregate root gets updated, and all referenced entities get inserted again. In other words, every change can be represented as either an insert or update statement for the root entity, 0 or more delete statements for non-root entities, followed by 0 or more insert statements for non-root entities. With this foundation in domain-driven design terminology and the Spring Data JDBC implementation, we can understand each of the ways in which the module was recently enhanced to use batching. Most commonly, business operations are performed on a single instance of an aggregate root and persisted to the database using the CRUD repository save method. Let's look at this scenario for the following root aggregate. Before the batching enhancements, non-root inserts within the aggregate are saved using sequential insert statements. After the batching enhancements, these same non-root inserts are saved using a batched insert statement. Sometimes business operations are performed on multiple instances of an aggregate root and persisted to the database with the CRUD repository save all method. Let's look at the scenario where multiple root aggregates are created. Before the batching enhancements, root inserts across aggregates are saved using sequential insert statements. After the batching enhancements, these same root inserts are saved using a batched insert statement. And looking at the same scenario again for a more realistic root aggregate with referenced entities, we can see the effect on a larger scale. Before the batching enhancements, non-root inserts across aggregates are saved using sequential insert statements. After the batching enhancements, these same root inserts are saved using a batched insert statement. Now for the same root aggregate, suppose multiple root aggregates are updated in the following way. In this case, the root aggregates are saved with their referenced entities removed. Before the batching enhancements, non-root deletes across aggregates are executed using sequential delete statements. After the batching enhancements, these same non-root deletes are executed using a batched delete statement. Finally, some business operations may cause one or more root aggregates to be removed. Let's look at the scenario where a single instance is removed using the CRUD repository delete method. It turns out that the rules that were in place to translate this into a set of SQL statements already achieves this in the most efficient way. However, that wasn't the case for when multiple instances are removed using the CRUD repository delete all method. Before the batching enhancements, root deletes across aggregates are executed using sequential delete statements. After the batching enhancements, these same root deletes are executed using a batched delete statement. And looking at the same scenario again for a more realistic root aggregate with referenced entities, we can see the effect on a larger scale. Before the batching enhancements, non-root deletes across aggregates are executed using sequential delete statements. After the batching enhancements, these same non-root deletes are executed using a batched delete statement. Out of the box, Spring Data JDBC includes support for the following databases using an abstraction called dialect to accommodate for vendor-specific functionality. All of the batching enhancements described here apply to all of these dialects, with the exception of the batch insert state enhancements for DB2 and Microsoft SQL Server. The batch insert capability requires the JDBC driver to support retrieving generated keys for batch operations through the statement getGenerated_keys method, which the DB2 and Microsoft SQL Server drivers do not support. If you want to pull these batching enhancements into your project, simply upgrade the version of Spring Data JDBC that you are using to 3.0, milestone 5, or greater. If you are using Spring Boot Starter Data JDBC, either directly or through the Spring Boot Dependencies BOM, you can pull these enhancements into your project using version 3.0, milestone 4, or greater. Thanks for tuning in. I hope you enjoyed this overview of the recent batching enhancements added to Spring Data JDBC.